So the next speaker, our guest speaker, part of the Strelka extended faculty, is Holly Jean Buck, who will be speaking to this question of governing simulations as a technology and as a motif, rather directly, and so speaking in ways in which I think that will demonstrate how the illiteracy, both in terms of the interpretation and deployment of these, can be extraordinarily dangerous. A few days earlier in this week, we had one of the guests to our program was Kim Stanley Robinson, whose a forthcoming book, Ministry of the Future, deals with questions of geoengineering and governance, particularly when geoengineering is instigated by those in the global south at a moment in which the governing institutions of the global north are in suspended legitimacy, to say the least. One of the things that where there were sort of strong points of agreement, and there were obviously many, but was that this term geoengineering, in one sense, both needs to be expanded and done away with altogether. That as we've been talking about in the program, to think of geoengineering not as a series of peculiar science fiction forms of climate intervention, but rather as ways in which it becomes possible for society to deliberately act upon the ecosystems in which it's operating. And it has to do with the definition then of the scale of designed and planned effect. And so it would include passive measures such as protection of the Amazon, as much as it would direct carbon capture, for example, as both the sort of let's say the sort of social and technological aspects of this as well. At the same time, the term is so broken and overcoded that clearly a different lexicon is needed to even to speak about this, lest one be totally misunderstood. Now, this is, so the reason I bring this up in terms of Holly is, you know, she's the author of a book called After Geoengineering, which Verso published last year, which examines, as she puts it, the best case scenarios for carbon dioxide removal. It is one of the foundational books of our reading list, the program this year. It is also, I think, one of the most important books that was published last year. Recommend that you take a look at it. She's currently a postdoctoral research fellow at UCLA's Institute of Environment and Sustainability. She is interested in how communities can be involved in the design of emerging environmental technologies. And so she's someone who works at that interface between environmental sociology, international development, and science and technology studies. She holds a PhD from sociology from Cornell, and also a master's in human ecology from Lund University in Sweden. Today, she's going to be speaking to us about what kind of, we're all talking about flattening the curve, what kind of curves matter, what they matter for, what their agency should be, and indeed what their agency should not be. And so with that, it's my pleasure to introduce Holly Jean Buck to our conversation.
Thanks so much. It's great to be with you. I know that we have a lot of Zoom fatigue, so I'm going to try to make this dynamic and relatively brief. What I want to talk about today is the limitations of governance by curve. Basically, I'm going to start by introducing 3 charismatic curves, which you may be familiar with. This first one is the curve of an idealized 2-degree scenario, and you can find lots of variations of this. The one I'm showing here is from the Royal Society's report on greenhouse gas removal, but there's numerous. They all basically look like this. They come from these integrated assessment models. So the image on the left is all these model runs that have been indicating that to curb warming to 1.5 or 2 degrees, we need to remove massive amounts of carbon from the atmosphere. So if you look at the simplified figure, you'll notice 3 things. The first thing is that curve bends down right away very steeply. The second thing is that by the end of the century, the world is removing more carbon than is being emitted. So there's that point of net negative emissions. But the third thing you'll notice is that this negative emissions processes, approaches, technologies, et cetera, they begin pretty soon, 2030 in this picture, which means that they're being planned and developed in the 2020s. So that's a curve that we're at the peak of, ideally, in this scenario, right? How do you remove that much carbon? These are the ways. I'm not going to talk about them in detail here, except to say that they've been mapped out, assessed, and there's a series of curves like this one from the IPCC's special report on 1.5 degrees that kind of show different combinations. So the curve on the right, P4, is with large amounts of geologic carbon capture and storage. The one on the left is with only afforestation, and it shows that kind of simplified representation. And maybe you want to say, that looks good, let's go for that one. But what's being hidden in there, in these tiny slivers of kind of brown acronym, afforestation and land use, is a terraforming project, right? I mean, the scales of afforestation, even in that P1 scenario, are incredible. And also it's contingent on everything with renewables going exactly to plan. And so I wanted to mention about the geologic approaches. There's two main ones that are discussed. This is the one in the models, bioenergy with carbon capture and storage. It too is a terraforming project at the scales of this idealized 2 degrees scenario. So that's growing biomass, combusting it in a power plant, separating out the CO2 and injecting it underground. The second one is direct air capture. I have a lot of numbers on here because it was for a more technical presentation, but this is often referred to as kind of a land sparing approach, because you could theoretically site these machines that suck carbon from the atmosphere where the geology is favorable for storing the carbon dioxide. However, they have a large energy costs, at least this first pilot generation, and it's thermodynamically, it's hard to see how you can escape this large energy cost. So they imply massive renewable installations to power this. So another type of terraforming implied with this choice of technology. And the other infrastructure that these curves imply is the pipelines, the injection wells for transporting the carbon dioxide to where it can be stored underground. So the 2 degrees scenario implies about 10,000 new industrial facilities on the scale of the ones we use today for carbon capture and storage. Currently, there's about 22. So basically an infrastructure for putting carbon underground on the scale of the existing fossil fuel industry, if not larger. And so those are some of the things that are implied in these nice curves. And because this is kind of hard to deliver, I mean, people have interpreted these curves as a prescription. So now that we have these curves, we're going to actually go and build this infrastructure. That's actually how it's talked about a bit, including by the fossil fuel industry, but also climate policy. It's this kind of consensus moment based around the curve that people are using in different ways. And because that's so hard, we have this other charismatic curve, which is the peak shaving diagram of solar geoengineering. So the idea here is that stratospheric aerosol injections can shave the peak off the curve we just saw, and that would lessen impacts and damage. Briefly, the idea behind that is that if you put particles into the stratosphere, you could reflect a small fraction, 1 to 2% of incoming sunlight. And so those particles would circle around the globe. This would be a global scale intervention, probably done by a fleet of airplanes that are specially designed for this purpose that operate continuously. Probably sulfur dioxide, because that's what's modeled and best understood, because we can look at volcanoes and what they have done, but there's some investigation of other choices as well. And why would somebody consider something so radical as changing the amount and type of sunlight coming down to Earth? It's because that it can look better than the worst case scenarios for climate change in modeling simulations that have been run. There's, of course, a lot of potential ecosystem consequences, which have been under-researched because of, in my read, disciplinary specialization. So ecologists would be less inclined to think that this is a worthwhile thing, spending their time researching, I think, because they understand the complexity of the systems. I'm actually strongly in favor of researching solar geoengineering, although you might miss that from my presentation, because there are a lot of really potential negative impacts that are important to mention. From ozone damage to interference with precipitation. The one I want to mention in the context of this talk is the termination effect. So if you see this plot by Kelly McCusker and colleagues, it shows what happens if you have warming ramping up, and then you start a solar geoengineering intervention. It brings down the temperatures, the global mean temperature, back to 14 degrees Celsius. And then if that is interrupted, the warming goes back up to the level that you would have had with climate change, which is much more catastrophic than the more gradual warming of climate change. So the third curve I want to mention is the narrative curve, which is, this is basically the kind of master arc of Western stories. There's a lot of variations, obviously, but you have an exposition, a rising action, a climax, a resolution. It's very much like the curve that we've been modeling, and I don't think it's entirely a coincidence. I think these things are informing each other. The thing that these 2-degree scenarios curves do is they put us at this moment, and Shell, who read lots of scenarios reports about what to do, and they have their own simulations that they run and popularize. On the back of their report, they have this passage from Julius Caesar that alludes to this moment, right? We're on such a full sea, we are now afloat, and we must take the current when it serves or lose our ventures. We are at that climax, at that peak. It's our choice. It's this epic moment in the story. And so my premise here is that trying to make reality conform to these curves is probably a narrative drive, but also a bad idea and a simplistic and even dangerous way to govern complex systems. And so I'm curious about how other dimensions can be added to planetary governance simulations. One proposition is that involving non-experts could do this. And I'm going to briefly mention a pilot project that I did with colleagues in Finnish Lapland, where we were interested if we could include communities into the research process itself. So what we did here is we went to 2 communities in Finnish Lapland. In Lapland, because there's been a lot of talk about Arctic geoengineering or regionally geoengineering the Arctic, either to stop tipping points in the Arctic or for the benefit of the whole globe. But there's been really no discussion of what people who live in the Arctic might think of this idea. So we wanted to go there, hold focus groups, interviews, talk to people about what they thought about solar geoengineering, what questions did they have, what would they like scientists to be modeling or focusing on, and then try to do some of that modeling and then return a year later to discuss it. And so a lot of the people we talked to were not neatly in a category of layperson or expert. There's this huge category of people that are somewhere in between that have a lot of expertise in their field that they can bring to bear. And so some of the questions that we got, a lot of questions are not things that we could answer with these modeling tool sets, but we could look at the winter conditions in Lapland and how they might change under geoengineering. And so these were some of the plots that were run by colleagues of mine. And then we returned to Lapland and showed these to people and had a discussion about them and what they might mean. And the effect was that it really illustrated to people what an early stage and how preliminary and some of this modeling is. And there was also this concern about what the curves and the graphs do, what work they're doing. They can seem as a truth carved in stone, as one community member put it. if you put a number, it becomes certain, and then that becomes a reference point. There's a danger that we lose the sense of what kind of issues we deal with, especially if you present this to politicians. And it made people even more curious about the things that weren't captured in those plots. So some of the takeaways from that particular project was that the climate preferences and questions people had aren't always obvious to outside experts or easily quantifiable. People have a care about more than what's happening right in their neighborhood. And the concerns weren't just about the technology and its effects on the climate, but the technology within this social context. And so I think that adding in that social context is part of the critical work we have ahead of us. And I want to talk for a few minutes about flattening the curve and the debacle, particularly in the US, that we're experiencing. So what could be wrong with the singular focus on the curve? In the case of the US, the temporality has been cropped to the certain period of interest. So first we had this 15 days to slow the spread. A lot of models are looking out to August, but if you look at some of the longer term studies, this is the Imperial College report, which famously influenced policy both in the US and the UK, the period of interest is actually much longer. And I mean, I don't know if it would even go beyond what they've shown in this graph here. So the curve that's being focused on is only a piece of the story. This is an article that came out last night as I was writing this in the Washington Post, misunderstanding the math. It's not just misunderstanding the math, although I'm sure there's a ton of that going on as well. It's misunderstanding the curve and what should be the object of analysis here. So as the columnist straight, Trump seems to have misunderstood and overlooked this. The model assumes a pattern of deaths that depends on this sort of tapering off. The estimates only ever went to early August. So this curve is doing a little bit of misleading work. A lot of misleading work. The second thing, this is a really interesting study. I encourage you to read this paper published in Science on the 14th of April. It's another modeling study done by a group of Harvard. And what they found is that actually they looked at these different levels of social distancing, right? So the green lines are a much stricter 60% reduction in contacts, et cetera. There's just a lot more here that could be discussed, but when it gets simplified by the media, it's this headline like, oh, Harvard tells us that we need to socially distance till 2022, because there's not this other group of experts who's discussing it in a multidimensional way. And so another thing that's wrong with the singular focus of the curve is that it's capturing narrow metrics like hospital capacity or deaths from the virus. But there's a lot of other things we care about, including these second or third order effects from the response, which also include things like deaths related to it. So you can see how it can snowball a bit out of control. I think that an interesting thing is it's the role of these experts to run modeling simulations. And so this is the very last sentence of a report by Imperial College. And if you read this, it's very similar to a lot of the papers you can see from some of the integrated assessment modeling on negative emissions, only that what they're basically saying is we don't know about the social effects. And why should they? It's not their job to figure that out, right? It's the job of these other people, but we don't know that those other people, the sociologists, psychologists, international development experts, international security experts, economists, ethicists, where are they in the room? Where are they in these conversations? So I think it's really important to consult diverse expertises in these types of situations. If you look at some of the guidelines that were in place about social distancing, it's pretty interesting. The US Centers for Disease Control has guidelines in 2007, updated in 2017, And you wonder if they thought about these second or third order effects. If you read it, they have a little tiny bit of nothing about employment losses this, on the scale of what we've seen, just about, plan for the possible reduction in income and consider maintaining a cash reserve. I mean, it just reads as something that was written by a certain class of experts that was out of touch with the reality of lay people. So I think that the curve and the focus on it has made people misunderstand the nature of the situation, and has some culpability in making things worse. And I really hope that we don't repeat this failure that we've seen with the response to COVID with climate change. I think that the curve is kind of hiding the real in a few different ways. But we still have a chance to transform our systems. We have a chance to start thinking about it in more multidimensional ways with consulting other groups of people. And I just wanted to mention a paper that we had come out last month about stopgap measures. We talk about solar geoengineering in this paper, but we actually look at a whole broad range of stopgap measures across environmental policy. And if we'd written that today, we could have added in public health policy too. You have to make sure that you're using that time you buy for something. This is true in the case of COVID. It's true in the case of solar geoengineering. If you're going to start this intervention, you better make sure that you're doing that other thing that you're buying time for. In the case of solar geoengineering, mitigation and carbon dioxide removal. Because buying time without using that time is like spending all of your money on a house and then setting it on fire, which is precisely what the US is doing with its response to the pandemic. And so with regards to climate change, I think that we should be having collective decisions and simulations about how to deal with residual emissions, because there will be some, but maybe we don't need, as much residual emissions as in some of those 2-degree scenarios. I think that with solar geoengineering, we also need simulations that can be collectively designed. We have all the creative and technical tools for doing these things now. More so than ever. We just need the social infrastructure to do it, the demand for it. And I think that we have to come up with other forms, which is why I'm excited to talk with all of you, because I think that you think in 3-dimensional ways, in much more creative ways than I do personally, and that a lot of people do. So these are the questions I leave you with. What does a collectively designed planetary government simulation looks like? What other shapes can it enable? How can we demand its construction? Thanks so much. Feel free to follow up with me afterwards if you have questions.
Thank you very much, Holly, for the excellent intervention. We definitely will follow up with you, and you'll be, we're very thrilled to be having you as part of the program ongoing. So we invite people to send additional questions your way.